Hi everyone, welcome back. I'm Sridhar Madhugiri. I'm a developer on the Visual C++ team, and one of the things I've been working on for the last couple of years is Windows 8 and the C++ side of supporting Windows 8. So I wanted to take some time to talk about what does it involve to move your existing apps to Metro. Of course, this is C++, so I'm focusing on C++ apps. This information has come from a lot of these questions we have got from different people, internally, externally, and so I want to sort of put together this slide. Half an hour is by no means sufficient. What I want to do here is to give you a high-level overview of the issues involved so that you can go away understanding what are the high-level issues and then plan accordingly. And of course, I'm sure there'll be a lot of blogs and other events, hopefully, to help you port your apps. So agenda, we'll take a quick look at what Metro SDK API is. Then what are the things you can do even before you start porting? What can you do to prepare your app to move to Metro? Then there's let's talk about the Win32 technologies that you use in your apps today, and what are the alternatives that are there. We'll go focus on the libraries that we ship, CRT, ATL, MFC, and see what are the options for you in Metro. And then we'll talk a lot about some of the common questions we have got and think about possible solutions. So first, I want to just take a quick look at Metro SDK API. I'm not going to spend a lot of time here. Essentially, there are three categories in my mind. One is the new WinRT APIs. I'm sure you have all seen those. So that's the first category of APIs. One of the interesting things you want to note there is any operation that can block is implemented as asynchronous operations, as asynchronous API. So get ready for dealing with asynchronous APIs. The second set of APIs that are there are the Win32 APIs that you already know. A lot of them are available in Metro. And the one interesting thing to note is if an API is not available, look to see if there's a similar API that is available in the Metro SDK. An example there is initialize critical section and spin count. It's not available in the Metro SDK, but the initialize critical section EX is. So when you're trying to port, there are some alternatives for Win32 APIs. And also, if you're using some OS COM components, some of them are available under Metro. But again, I'm not going into details. The best place to go is the documentation that's online and see what's available to you. So how do you identify? So you have an app that runs on Win32 on the desktop. How can you identify the non-Metro SDK usage, non-Metro SDK API usage? Docs is one place. Of course, you can go see what are the APIs you use, go look for each of them in the docs and see if it's available. The other thing is there is a preprocessor defined that you can use. If you start building your app with this defined set, the set of APIs that are available under Metro are the only ones that are available for your application at that point, so you start getting compiler errors on APIs that are not available. Of course, this can be messy because if you have a lot of APIs that are not available, compiler stops after 100 errors, so you may not get the full list. The third tool that's available to you is the certification kit. Essentially, it requires you to build an Apex package and run the tool on that, and it will flag all the APIs that are not available. So there are some tools available to you to find out what's the work involved. Let's talk about, even before you start porting, what can you do to help with moving your apps to Metro? So first thing, build your apps with VS11. Because as you start targeting Metro, you have to build with the VS11 compilers. So build with the VS11 product. Build your desktop app with VS11. Test it on Windows 8. because by doing that, you are basically absorbing the changes that are there in the language, in the C++ language, in the C++ libraries, and also any incompatibilities that app compatibility issues you may have with your app running on Windows 8. So that's a basic step. There's no need to port anything. I think just getting your app running on desktop on Windows 8 would be a good first step. The next thing to look for is, hey, you know what, am I using some of these APIs that are banned? And are there easy alternatives that are available under Metro? If so, just use the APIs that are available under Metro, remove the other APIs that are not available, still build your app, run it, test it. I'm sure you have a lot of test infrastructure that runs on the desktop today. So by making these changes and running on the desktop, you can test your app to make sure it's still working as you make these changes. This is the big one, asynchronous operations. So there's two sides to this one. One is you are consuming APIs today in Win32 that may not be asynchronous. So for example, if you open a file and start reading, you can do it asynchronously, but most people read these files synchronously. So now the thing to think of is can your app handle asynchronous operations? Do you have to refactor the code? Do you have to, it really depends on your application, but do an assessment of your app to see how asynchronous operations affects your app logic. One of the things I want to point out is refactor your code to say, hey, if I get partial data back, can I handle it? How do I keep the UI responsive when I'm reading a file that may take a while, or I'm getting some file from a network? How do I keep my app responsive? If you already have some of those techniques, it's easier. If your app today blocks when some operation takes a long time, then you have work to do there. The other side of this is, let's say in your own logic, you have some long-running operations. When you port it to Metro, you really want to keep the UI responsive. You want to make these long-running operations asynchronous. So this is the other side, your own code. Try to make this asynchronous. If you already have your app factored in such a way that when your long-running operations are running, you're still responsive, I think it's going to be easy for you to move. So one thing I was thinking was, OK, you know what? Today you have a desktop app. You have a long-running operation. Try running it on a different thread and wait for it to complete in a non-blocking manner for the UI. The other way is to say, you know what? I'm just going to now create a new asynchronous API on top of my synchronous one, and all that the asynchronous API does is calls this long-running operation on a different thread. So techniques to help you move. And so asynchronous operations is very important when you port to Metro. The other thing is, yes, let's talk about your core application logic. Is it insulated from the platform code? Are there a lot of calls in your core logic where you say, oh, I want to read a file, as opposed to saying, OK, here is your core logic, as opposed to taking a buffer or a collection. If it directly reads a file, then you may have issues there because file APIs have changed. Things like that. One thing to think of is, can you refactor these direct API calls into abstractions and isolate that platform-specific code into abstractions that then you can easily port to Metro. The other thing to think of is use standard C++ libraries in your core logic. Make sure that your core logic can work under Metro or desktop. Use standard C++. All of these should be easily portable. And isolate all the APIs that you call in the OS to an abstraction of its own. So operate on buffers, operate on containers, things like that in your core logic, and separate out how you read the data in from somewhere. So this is something to prepare your app. Even without doing one line of porting to Metro, you can help move your app, make it easier to move your app to Metro. So now let's go into the technologies that's there for you and see what are the big places where you need to worry about and where it is easy. UI. Okay, user and GDI. I'm sure a lot of us have apps that use user and GDI, HWind, and it is not available under Metro. Previous talk, Tim talked about XAML. It's a modern UI. You can use that, but you have to rewrite your UI. There's no way you can move existing UI to Metro. So that's a given. DirectX is available in Metro. Most of that code should be portable based on the version that's available. I think it's DirectX 11 APIs is what is supported in Metro. So if you're compatible with that, most of your code should be able to move to Metro very easily. One of the things I suggest is when you have an app in Metro, there is a lot of startup code that you need to run. And the DirectX template sets it up for you. So one option I was thinking, I tried doing this with some sample earlier, and the easiest way was to say, create the DirectX Metro template project, go take the core logic of DirectX that you have and put it into that template at the right places, and then basically, for a simple sample, it worked. I'm sure there's hidden issues, but that would be a good starting point. So what are the options? XAML and DirectX. Those are your options under Metro. So be ready to rewrite your UI if you're using Win32, user and GDI based you. MFC. It's not available under Metro. MFC targeted Win32 and user GDI. We have not ported MFC to Metro. So you have to plan for a rewrite here as well. So options, again, if you have UI, and you can choose XAML or DirectX based on what your app does and what capabilities you get from each of these. One of the things to think about is MFC has some type of data binding already built in. And Tim talked about data binding earlier. So if you have form-based applications that were typically data bound to some data set, think about moving to XAML-based data binding. Utility classes in MFC, it's like we had these containers and a few other things. Those are also not ported. Consider moving to the ones in STL or CRT. So they are still available. You can use those. So let's go to libraries. That was the message where you have to rewrite. There's no option. Let's talk about other libraries that we ship with C++. So CRT is the big one. Let's talk about CRT. So a subset of the APIs is available in Metro, a big subset. The next slide actually goes through and talks about which APIs are not available and why. But in general, if a concept that was wrapped by an API is not available in Metro, then we chose not to have it available for your apps in Metro. We didn't want to go and try to say, hey, you know what, there is no console in Metro. We'll try to fake up a console somewhere and let you use it. The concept is not available, so we didn't enable it for Metro. There are certain APIs available in Metro, but we don't recommend you use it. A typical one is the file API. There is open and read, write, all of these APIs, file APIs. But they are blocking because the spec says read is blocking, write is blocking. And so since the recommendation and the guidelines for Metro application is to not have blocking operations, we don't recommend that you use this. Move to the file APIs that are there in Metro. Don't continue to use this. ANSI character functions are still there, but typically most of the APIs or all of the APIs in Metro are all white character APIs. There could be some reasons that you may want to use this, but again, not recommend that you write your app with typically everything that handles ANSI strings and then try to convert between ANSI and Unicode every time you go to an API, make an API call. Okay, this is the big one. What APIs are not available? MB, the multi-byte APIs, string APIs are not available. Again, as I said, primarily wide character set API set is available in Metro, so move your apps to Unicode. I'm sure it gives you a better experience than to worry about which code page and things like that. Process control, so spawning an application or all these things, there is no easy way for you to spawn an application in Metro, so those APIs are not available. Create process is not available. These use those Windows APIs, so those APIs are not available. Again, threading. Threading is available in Metro, but it is based on a thread pool. Begin thread means create a new thread, right? So create thread is not available in Metro, so begin thread does not make sense for us to have begin thread here, because the model in Metro is for you to use the thread pool for your background processing and asynchronous operations, not to create your own threads and control its lifetime and things like that. And there are good reasons for it. I'm sure it's been talked about. So let's walk the rest of this. Heap and stack functions. So obviously, you cannot create your own heap. Environment, there's no environment blocks and things like that, so you don't get these. And then, as I said, console earlier, and some of these port functions and pipe functions, which are not available under Metro. So again, how do you find out whether it's available? As soon as you throw the define I indicated earlier, and you build your app, all these APIs are not available to you, and you get compile errors. So this is CRT. Let's talk about, before I go to ATL, let me talk about STL, because I don't have anything here, but why do I not have anything? Because everything in there works under Metro. We did not disable anything in there. I suspect there could be some issues with anything related to threading and the new classes, but in practice, nothing is, I don't know of any APIs that we have disabled. Again, the console APIs would be, again, the same thing. I don't think you can use it, although we may not have disabled that. You can't use it because there's nowhere for that output to go. ATL, again, a subset of the APIs are available. And here I'm talking more about what APIs are available, because it's a smaller subset than CRT. So you can write a DLL server with ATL. You can have COM objects. We don't support iDispatch under Metro in ATL. We support only CString-W for the same reason I talked about earlier about white strings. Then the ATL container classes, which are we have map, and I don't remember the exact names, but we had these MFC containers which were ported to ATL. Those are still available for you to use. Then there is the critical section, mutex, all these synchronization objects. Those are still available to you. Some of the variant, safe array, and beaster, they're still there. So if you have COM components that are really about business logic, not related to UI, most of those should be portable directly to Metro. We'll talk a little bit about whether you can use COM objects in Metro later on, but ATL is still available to you. Okay, porting. I just said porting here because this is a set of different types of questions that we have got, and I think this is the most useful. This one and the previous part were the most useful things in my mind. So let's go over this and talk about all the issues we have hit. Static libs. Do static libs work under Metro? There's been a couple of issues. There have been some warnings and errors, and there have been these issues. So I just want to clarify what it is. If you have a static lib that's just using standard C++, it's completely supported. There is no issues with that. You have to worry about using Metro SDK APIs only in those static libs, but you can use them. You can use static libs. There is no problem. Now, let's come very specifically about using WinRT APIs or authoring WinRT components in a static lib. Consumption of WinRT APIs in static lib. So you have some code, and you say, hey, I want to open a file here. and you want to use the Winarti APIs. It is possible to do that. It's completely supported both under C++CX and WRL in beta, and I don't know exactly when it's going to be fixed, but there were warnings, there were errors. That has been fixed, and by the time we ship the final product, those warnings, errors should be taken care of. So I'm jumping ahead a little bit here because we have two technologies, C++CX and WRL. Both of them support consuming Winarti APIs in static libs. Now, authoring Winarti components. So what you want to say is, hey, you know what, I want to create a Winarti component and put it in a static lib, and then my final binary is going to pull it in and expose it as a Winarti component. Using C++CX, we don't support it. There are certain issues that basically make the experience really bad, so we just said we don't support it for this version. We are going to look at it in future, see what we can do to support it, but for this version, it's not supported. How about WRL? It's sort of the same issues that affect C++CX also affects WRL, but since WRL is more a library type thing, we can definitely, I mean, there's two differences here. In C++CX, the metadata is part of your OBJ files, whereas in WRL, metadata is not, and that's where some of the issues come in. But some of the issues are common. In WRL, it's partially supported. By partially, I mean, yes, you can do this, but you have to take extra steps by using that macro that's there on the last line to make sure that that OBJ gets pulled into your final binary. I don't want to go into the details of how static libs work because that will take its own 1 hour duration. If you have questions, I can definitely, I'll stay here and I can answer those in more detail. Using existing code in Metro. So you have written C++ code, and you have static libs, you have DLLs, you have components. Can you use them? Absolutely. You do not need to make them as Winarti components or give them a Winarti API. So let's talk about C++ static libs, right? So only thing you need to worry about it, make sure that your existing code is ported to use the Metro SDK APIs, but you can still use in all of these. Link to the static lib or import lib as usual, and then make sure that if you are using a DLL, it's included as part of your Apex package so that it's app local to the application. That's the only way you can consume DLLs that are not part of the system. Using COM components, absolutely. You can use your COM components in Metro. Again, it's app local. You have to create a reg-free COM manifest, and once it's there and you wire up the reg-free COM activation in the app and your component, it'll work. There's a new API, co-create instance from Apex that you need to use, but that API is very similar to the co-create instance, so it's not a big change. But reg-free COM is some work, and there's definitely documentation as to how to do that. Convert types to Winarti types. Okay, so you already have code. Do you want to convert those types to Winarti types? I'll get to questions soon after. Do you want to change your types to Winarti types? Yes, sometimes. Why? If you are frequently going to pass this data across the Winarti API boundary, and it's costly to go between your native type and the Winarti type, you may want to consider converting it to a Winarti type. String and array, when you use them as input parameters to Winarti APIs, there's ways that we can what we call fast pass or borrow semantics to sort of say, hey, this is actually a Winarti type only when they are used as input parameters. So there are tricks to use there. But this doesn't work for everything. Containers and collections. If you're using STL types like standard map and vector, do you want to convert it to platform, map, or vector? Again, it depends on your usage. If you're going to be modifying the contents of these containers often, you may have a little bit extra overhead if you use platform types. But if you're actually passing these containers across the APIs very regularly, it does require a copy. So again, you have to look at the trade-offs and decide which one is right for you. Okay, so how do you decided that you want to convert your existing component into a Winarti component for various reasons. You decide, okay, you know what, I have this component, it's really useful, I can use it in different apps, or I want to use it using different applications, and you decided that you want to convert your component to a Winarti component. Choose the technology. C++ CX is there, there's WRL, or you might write your own implementation to author Winarti components. So one of the things that you may think of is the very easy way you can think of doing this is to just say, hey, create a Winarti wrapper, and all you do is delegate to your existing code to do the real work. So you're just creating a thin wrapper over your existing code, which is Winarti, and you're done. Or you might choose to say, I'm going to rewrite the whole thing using whatever technology you choose to use. But we think the wrapper may be sufficient for most cases. I don't think you want to go change everything from day one. Again, it's a case-by-case basis. Converting COM components to Winarti, right? So that was the previous slide was just C++ code. How do you convert COM components? Again, if your component is already written with ATL, it may be easy to move to WRL because they're very similar concepts. Yes, you have to do a little bit work, but it should be fairly easy to do that. What are the steps? I've written down the steps there. I'm not going to go through all of them, but it's there. You can always refer to that when you go back to the slides. Okay, so let's just talk about what are the technologies available to you. There is a lot of different technologies. Okay, CRT and STL, use it in your Metro apps. Absolutely. There are certain parts that you don't have that are not available, but if you think about STL, all the container classes are available, all the algorithms, everything else is available. The place where you start hitting these issues is with APIs that talk to the platform. So something like writing out to console, there's no console, so it doesn't work for you. As far as Winarti, if you want to consume or author Winarti components, you have C++ CX, which is a set of extensions. I'm sure Herb talked about it earlier, and there are other talks that go into that. And then there is WRL, and I'll talk about that later on in the afternoon today. And UI. So you have XAML, which is a modern UI for C++. We have had these questions often. Hey, you have Win32, you have MFC. What about all these people who have Silverlight and WPF, and they can easily do a lot of things without having to worry about writing all of that themselves. Now you do have that. XAML is there for you. And there's DirectX. Again, if you have a lot of graphics intensive apps, you want to do a lot of animation, DirectX may be a better choice. Again, there are talks about DirectX as well in the afternoon, so you had a talk about XAML. Will help you figure out what's the right choice for you. So just in conclusion, based on by no means have I covered everything. I just wanted to sort of highlight the important issues that have come to mind. It's half an hour talk, as no way does justice to this, but this is just setting the context for you to start thinking, and then I'm sure we'll have other resources. Metro SDK, there is work involved to move there. But it's not all throwaway. Anything that you have that's purely C++ code should easily port to that platform, to that environment. A lot of business logic and core application logic, where you're doing you have your own proprietary sort of I'm missing whatever. Anyway, your core application logic should be portable. as they don't normally talk to the OS on a regular basis because it's their own algorithms and things like that. It should be portable. UI, again, DirectX, easy to port. Win32, you have to rewrite using one of the options. C++, you have two ways to interact with WinRT. One is the C++CX and WRL. Use concepts that are familiar to you in C++. There's no need to stop using them. Even if you write a Metro application from scratch, for most part of your application, we expect that you'll use concepts and techniques that you already know with C++. And only in the parts that talk with this system do you have to worry about WinRT. The other thing I want to also note, I mean, this is sort of a thing that comes up every time we ship a new version of Visual Studio or a new compiler, is build, test, and validate. And make sure you actually do that with the release configurations as well. Don't wait till the end before you start testing your release configurations. That's about it. And so we can have a few questions. Go ahead.
So you mentioned earlier that Metro support using an existing COM component.
Mm-hmm.
But what if the existing COM component itself is using APIs not available in Metro?
As I said, as you have to port your component to not use Metro APIs, but if you can change your component to not use any Metro APIs, you can definitely, you don't have to make that COM component into a WinRT component. It can still be a COM component, except that now you had, for everything I said here about porting, you have to first make sure that you only use Metro APIs. You remove any APIs that are only in the desktop. Once you do that, you don't need to go and rewrite your COM component into a WinRT component. Yes. No, you have to make the COM component compliant.
In my case, the COM component comes from another component. So I have to ask them to do that?
Yes. Because the only way you can, I guess, let me repeat the question because I forgot about that. So the question was, if my COM component is not compliant, do I need to make it compliant? And if my COM component uses other COM components, do they also have to be compliant? The answer is yes. All of these components have to be compliant. The only way you can actually activate non-OS COM components is to actually include it in your AppX package, app local. And so all of those binaries that are in that AppX package have to be compliant. But my point about COM components was you don't need to now go make them into WinRT component. You have to still make it compliant. So Metro SDK compliant means you're not using any desktop APIs, right? But you don't have to now say, I have to rewrite my COM component in a different way. I mean, the interface is still the same for the COM component. Everything else is the same, except that internally the APIs it uses has to be part of the Metro SDK. Yes. Yes.
So we can have Sridhar. Harry's ready.
Yeah.
Sridhar will be there, and we'll have lunch. In half an hour, we'll have the panel Q&A, so you can ask him as many questions as you want.